So I am really pleased for us to turn our attention to our main theme for today. That is SimpleFM. Tony Peterle from WorldCast Systems is ready to talk to us about it, answer your questions, and show you why this is a good thing. Tony?
Roger. Thank you, Barry. I appreciate the opportunity to come talk to you. The technology that we're talking about is called SmartFM. It is the first artificial intelligence and sort of at the vanguard of what's being called the decarbonization of FM broadcast. Basically, what it is a way for you as an FM broadcaster to save on the electricity consumption. So it can reduce your cost and it can reduce your CO2 emissions to help protect the planet. In case you hadn't realized it, unless you're doing TV, and even TV not so much anymore since they got rid of all the big high-power UHF stuff pretty much, FM transmitters are the biggest energy hogs in the whole FM broadcast chain, no surprise. Studios and your transmitter links and things like that aren't really drawing all that much power, but that's the main job of the transmitter, is to suck up power from the electric mains and turn it into RF and some heat. So just how much, what does that really mean? Well, back in 2018, the BBC did an overall energy survey, and they estimated that their FM broadcast services consumed about 100 gigawatt hours per year. So yes, so reducing costs, reducing CO2 emissions. FM transmitters are big energy hogs. Here's the pretty chart that goes along with that BBC report on their energy consumption, about 100 gigawatt hours per year. They don't have that many transmitters in the BBC FM services, so that number actually includes their estimated consumption of the receivers that were tuned to the BBC services at any given time. As far as just transmitters are concerned, we got a much better estimate from TDF, the biggest broadcaster in France. They have 5,000 transmitters deployed. They burn about 450 gigawatt hours per year, and that's just on the transmission. Germany, we've got over 1,000 deployed transmitters deployed in Germany, and they are generally lower power rigs, so they're only using about 6.5 gigawatt hours. That's primarily with our customer Uplink in Germany. We'll hear more about them here in a little bit. So I took a wild stab at estimating how much energy is consumed by FM broadcast transmitters here in the United States. So these are just completely thumbnail wild guesses, but we have about 11,000 FM radio stations in the U.S. 6,600 of them are commercial, 3,900 nonprofits. We got some LPFMs, so just generously, I said, let's say the average output power is a kilowatt. It's probably less than that. Let's say the average efficiency is 72%, and you come up with the figures that we see on the right. So 15,000 kilowatt hours, or 15,000 kilowatt instantaneous. It adds up to about 135 million kilowatt hours per year. So that's, I think, about 13 gigawatts. But anyway, the upshot is we're burning a lot of power, and that power is getting more expensive. Of course, we had the big spike that happened recently, but electricity costs have been gradually and steadily increasing. Nobody is expecting that trend to go in the other direction. So the power 5 years from now or 10 years from now is probably not going to be any cheaper than it is right now. And it's vastly different. The power rates in the United States are insanely low compared to what we see in other parts of the world. But again, the trend is that those prices are increasing, and they're not likely to come back down. So what can broadcasters do to be better stewards of the planet and save some money on their own electricity costs? Well, there's several options. You can eliminate the extra gear at the transmitter site by building stuff like RDS encoders, sound processors, IP audio codecs, and things like that. Those are now integrated in the transmitters for the most part. So you reduce the hardware count at the site, which reduces not only the direct consumption, but the cooling load at the site. And we've also done a lot of improvement in the hardware efficiency. We're getting close to the theoretical limitations of the LDMOS technology that we have currently, but everybody's been pushing with more efficient power supplies and more efficient designs. optimization of the boards and all that kind of stuff. And so we're getting the transmitters now, FM transmitters from power input to RF output are now hitting 76, sometimes even a little bit more in terms of their overall efficiency. And that's impressive considering where we came from, 10 or 20 years ago. But again, we're getting close to the theoretical limits there, and we're still throwing away almost a quarter of our power as waste heat. So we started thinking about this a number of years ago and said, well, how can we reduce our electricity consumption? Well, one of the options is to reduce the power. This is an example of a translator site in Port Arthur, Alaska, that adjusts their output power at various times of the day because during the day, they've got the fishing fleet out on the water. They need more power to reach everybody out there. At night, the fishing fleet comes home and they don't need so much power to reach the people that are close by. Beyond that, there's not a whole lot you can do without really thinking of something sort of disruptive and looking at it from a new direction. And so we started looking at it from the listener standpoint. Obviously, if you reduce the power on the transmitter, the RF power in the field is going to be reduced by a similar amount. Of course, you've got the inverse square law going on, so it doesn't vary as much as you might think, because it's the distance from the tower that makes the biggest impact on your signal strength in the field. So one of our resident geniuses by the name of Daniel Verbrugge started sculling about this and realized FM receivers by and large are a lot better at acquiring and locking on and staying with a signal than they were 10 or 15 or 20 or 50 years ago when the FM rules were laid down. So the receivers with phase lock loop and everything else were really kind of helping us out. And then the other thing that he realized is that nobody is driving around in their cars or has on their portable radios or even most home radios a signal strength indicator. The primary way that we broadcast engineers would use to measure the quality of the signal in the field is not what our consumers use. They use their ears. Just like sound processing, the quality of the signal and its listenability is a very subjective measurement. And so our team set about to analyze that interface, that crux of what makes a signal not listenable from the consumer standpoint. And so to do that, we did a lot of double-blind testing with different types of listeners, different levels of expertise in audio and broadcasting, different types of audio and different types of RF disturbances or echoes or reduced signal, and did the subjective tests so that they could tell us when it had an impact, when the signal was becoming affected. So from that, we developed the algorithm that does the analysis of the audio content and determine how resilient that audio content would be to any effects of the reduced RF in the field. And from that, an algorithm that can predict and analyze the audio signal, predict what the resilience is going to be to the interference of the field, and calculate the amount that the power can be reduced safely without having an impact on the listenability of the signal. So SmartFM ends up adjusting the power several times per second based on the broadcast content. And you can see a measurement there on the right, the maximum power on that. And we're set for about 866 watts, or roughly. I can't read the small lettering there, but the maximum power, goes up to 900 or even close to 1,000 watts. The reduced power can go down below 600, even below 500 watts. You can see we're almost reaching 400 watts. And those excursions below the set power limit are not affecting the listener. They're not affecting the coverage, but they are affecting the power bill. So from that RF adjustment in real time, you then get the electricity savings in real time. And that's what adds up. A few pennies and a few watt hours here and there is what adds up to make the big impact in the savings in carbon emissions and electricity costs. So the whole concept, again, is just it's a psychoacoustic analysis of the program material. Of course, this currently is available only in our Acriso transmitters. So we control every aspect of the modulation. We control the RDS. We control the RF amplifiers, the power supplies, the fans. All of that is under the control of the algorithm. And so we measure the audio robustness. We calculate the gain or gain reduction with the embedded AI. And then we make the real-time adjustments in the RF output power. So, of course, we had to put this to the test and see what our customers and their listeners think about it. These are some of the reports that we got back from the initial testers. Radio France did some of the early testing and confirmed that our testing was valid, that they are not hearing any differences in the coverage. They don't notice any decrease in the quality of the audio. And they are seeing, noticeable improvements and cost savings. So we did our first demo installation here in the U.S. at WVLI in Kankakee, Illinois. I had the great pleasure of working with the late, great Gary Klein for a couple of days. We put the technology on the air, and then we did some drive surveys around the fringes of the coverage to see what the differences were with Smart FM on and off. Those were not double blind tests because there were only the two of us, so we knew full well when Smart FM was enabled and when it wasn't. But we were really working around the edges of the signal, really trying to detect any differences. And quite honestly, the only difference that either one of us noted was in the very distant fringes of the signal where it was essentially unlistenable anyway because of static. The Smart FM would make it slightly worse. But any place where it was a listenable signal, turning the Smart FM technology on or off made absolutely no difference in the listenability. It was really quite impressive to see it in action. So obviously replacing an old transmitter with a new transmitter, you're going to get a lot of efficiency there, moving from the mid 60s up into the mid 70s in terms of overall efficiency. With Smart FM, though, it's even enhanced. You can increase those savings even further. Other aspects that it helps out, of course, the overall cooling. Transmitter is not going to generate as much heat, so you can have lower temperature in the building. The components last longer because the transmitter is running at a lower temperature, less maintenance, less repair. It's just there's a whole lot of benefits that come with being able to vary the power like this, in addition to the direct electrical savings. I mentioned Uplink. They were an early adopter of Smart FM. It was one of the factors. They did a project, I guess it's been like 4 or 5 years ago now. It was about a $5 million transmitter project right across Germany. And they chose the Acriso transmitters based on the quality of the signal. And also they liked the thought of Smart FM. And they're running it now on 400 plus transmitters around Germany. And they're seeing an average of 10 to 20% savings with Smart FM, which is, that's no great, it's like we can do up to 40%. The limiting issue with Germany with Uplink is Germany has a regulation of 0 dB MPX power. MPX power is a calculated measurement over 1 minute of the density of an audio signal, how much it's compressed. Typical competitive FM stations in the US are running 6 to 8. I've even seen 10 or even 12 dB of MPX power. So that's a really heavily mashed signal. In Germany, the regulation is you're not allowed to have an MPX power reading anything over 1. So you can't, the outgoing audio can't be any more densely packed than the original source material. And most of the broadcasters that Uplink leases their transmitters to are educational and talk formats. So it's a very low density audio, and they have the limitation on the MPX power. Still, they're clocking 10 to 20% savings with Smart FM. And when your electricity costs are 25 cents, 30 cents a kilowatt hour, that can definitely add up to some financial savings, as well as the panache, the green feather in your cap to be able to say they've started a whole publicity campaign for their company in Germany now, saying they are the leaders in the decarbonization of FM broadcast. So it's position they can take. It's helpful for the planet, and it saves them some money as well. So definitely a win all the way around for them. SmartFM is generated on an annual license. We can do an annual or we can do a perpetual, depending on what your needs and preferences are. We are still actively looking for testers. We've got one now in Colby, Kansas. KTCC is our current SmartFM tester in the US, and they're seeing about 20 to 25% savings. That's similar to what WVLI and Kankakee, they had an oldies format, and they saw 25, 30% savings on their electrical costs as well. So as I mentioned, it's available currently on the Crizo transmitters. We make transmitters from 100 watts up to 10 kilowatt. Our new AIO series, IO series, is just been introduced. We introduced with the 600 and the 1 kilowatt. We'll be bringing out the 100 and 300 watt versions of the AIOs at NAB here next month in Vegas. So it is compatible with all the Crizo transmitters that we've delivered in the past, well, since 2010, so the past 13 years. It's more than 14,000 transmitters in the field that are already ready to go SmartFM with just a software upgrade. It's a patented technology, so it is something that we could conceivably license to other manufacturers should they want to integrate the SmartFM capability into their own designs. So turn it on, and the software is pretty simple. You activate the algorithm, you pick the best strategy. Usually the standard works out pretty well. These are our current testers and customers of SmartFM. And we've got over 500 transmitters running with SmartFM already across the world. It does require a STA in the US at the moment, because SmartFM does run afoul of the FCC regulations on maintaining your power between 90 and 105%. There is some gray area because the FCC says, well, if it does drop below 90%, you have, I think it's a week to notify them and 30 days to fix the issue. And whereas with SmartFM, if it drops below 90%, it's probably going to go back above 90% within the next few minutes, if not the next few seconds. So the FCC is aware of what we're doing. They approve of what we're doing. I've run a couple of the STAs myself, and it's a very dirt simple process. Just have the right language to put in there, so they know what to expect when they see these applications coming across now. So obtaining the STA is usually shouldn't be a problem, but we're happy to help out with anybody that does want to help test. And that's what I have as far as the slides I have. We can have a more open discussion. I've got some results slides from the Colby, Kansas installation we could look at, or if there are any questions about SmartFM or any of our other technologies or products, we're happy to help out.
I have a question. Are there particular formats that are more conducive to using this technology?
Yeah, it's basically the denser and louder the audio is. So if it's a rock and roll station or top 40 station, one of those, like I said, with the MPX power levels up there in the 10 to 12 dB range, that's something that could work quite easily and get better power savings. Because essentially what we're doing is we're masking the artifacts of the reduced signal behind the audio. The reduced signal usually is going to start to manifest itself first in a little crackly static. And if the density of the modulation and the nature of the modulation is strong enough to cover that up, then the effects of the reduced signal are not going to be audible. And therefore, as far as the listeners are concerned, they don't exist.
Tony, have you done any testing of this system with PPM encoding?
Yeah. And because the whole system is going up and down together, the PPM encoding travels right along with the doesn't seem to matter about the reduced signal levels.
Just wondering about long-term implications for actual rating results.
It's certainly something. I mean, none of our testers here in the US have been in PPM markets. And certainly we know that the type of compression that you use on your MPX transport, if you're sending MPX over IP, we know that can have an impact on the PPM encoding. But again, because the signal is changing several times per second, I would not expect it to have any negative effect on the PPM encoding.
How would you say that the algorithms for SmartFM compare to those used in MDCL on AM?
I really haven't analyzed the MDCL algorithms a lot, but the theory is essentially the same. If you've got enough modulation to cover the artifacts of the reduced RF, then you've got an opportunity to save some power.
Now, does this come in steps? That is, you said 10 to 20% for some stations. You're monitoring the audio, but not the listening locations. If we have lots of bad sites, can we say, do this thing you do, but do it a little gentler?
Yeah, you can go with a gentler version of the algorithm, but really the amount that you can crank it is going to be based on the audio. It's really dependent on the audio. And if the audio is loud enough to hide the effects of reducing the signal.
But in some places you're fighting terrain. In some, you're just fighting distance over flat terrain. It's still going to drop to a noisy place, but you might want to be able to say,
yep,
we use a lot of this. We take it very gently because we're San Francisco everywhere.
Yeah, exactly.
Versus this is the prairies of West Texas, and the edge of your signal is the limitation of static and interference from other stations.
Yep. And we have several different levels of the SmartFM in the software. So if the standard level isn't working for you, you could use a more gentle, attack that is not trying to save quite so much power, but it's going to leave your signal strength up more of the time. Then there's a more aggressive. If you've got a particularly loud station and you really want to push the power savings. We've got a couple of stations that are running on renewable energy. They're running on wind and solar. And so for them, being able to use the SmartFM could mean the difference between being able to broadcast 24 hours a day and not. So it's all in accordance to your needs.
I see in the comments here that Kevin has chimed in to say that if there's an STA required, that you will pay for that to be filed.
Yeah, we're paying the filing fees for anybody that wants to help us, gather data, and because eventually we'd like to file for a rule change with the FCC. I've already broached it up with the NRSC in one of their meetings last year, and eventually we'd like to see a codicil or a clause added to the power rules that says, you can go below 90% power as long as you return to 90% or better within 5 minutes or 10 minutes. Something that would make it, would make it possible for broadcasters to use this solution without having to file for a special license.
It's mentioned here that it will not work with HD transmission.
And then a theory that definitely needs to be tested. My thinking is because it would affect the level of all of the HD subcarriers simultaneously, it might still work, but empirical testing or smarter theoretical minds than I need to think about that.
So is testing underway or
not by us? No, we don't do HD. We don't have any intentions to do HD. We're strictly analog only because that's the vast majority of our business around the world. Just like we're 10 kilowatts and under because that's the vast majority of our business around the world. So we don't have any intent to. Yes, it would work with a synchronized booster. I see the question from Tom in the chat. I'm not sure what that would do to your mush zones though, because if you're varying the transmitter power, it's not your mush zones are not going to stay in the same place because of the inverse square law. So chances are would not work with SFN, single frequency networks.
What about receivers? With digital receivers, obviously, tuning isn't a big problem, but there's still a lot of analog receivers out there. Have you done any testing of the tunability of the analog receivers?
Yeah, actually, like I say, our resident genius Daniel Verbrook, who's an old ham radio operator from way back, and so he tested with old analog receivers, but basically even analog receivers, unless they were built, before the 70s, they're going to have a phase lock loop, and so they're gonna stay on frequency, and generally the AGC and the front stage of an FM receiver is more than enough to cover the fluctuations in RF that the smart FM generates.
So I guess what I was getting at is when somebody's trying to tune in a station, is there any impact to their ability to do that?
No, again, because the power is changing several times per second. So it's, for them to come across a frequency and not detect a station there, and then suddenly Smart FM adjusts and there is a station there, we're talking about much smaller adjustments than that. So Kevin, I don't know if you have a price list handy, or if somebody's looking for the typical cost for a 5 kilowatt transmitter. I think we're in right around the $42,000 range. I'm not sure for a 5 kilowatt FM. I know that, and I have been extending homages online, and I thank them all in person when I was at the factory a few weeks ago. Our procurement and production team has done an incredible job through the component shortage and everything that's happened, the supply chain issues and whatnot. We were able to deliver all of our orders in 2021 and 2022. And our lead time on transmitters is currently 3 to 5 weeks. In fact, we have some of the lower power ones on the Kevin says he'll get back to us on the pricing. Yeah, so we really have done an excellent job of keeping the pipeline filled. We've got some of the smaller power. I think we've even got 3 kilowatts in stock in Miami, but the 5 and the 10s are running 3 to 5 weeks for delivery times. And if you'll give me just a second, I'll open up this price list here and give you a better idea on the list for a 5 kilowatt. 5 kilowatts. So the 5 kilowatt comes in a couple of different flavors, and it's based on the redundancy. So the basic list price for the basic 5 kilowatt transmitter Acrezo is $39,900, so just under $40K. If you go for the full redundancy, you get extra power supplies, you get a dual drive, so an extra exciter. You get double the number of circuit breakers, so you can run it on 2 different power sources, double the number of cooling fans, double the number of cooling fan power supplies. It's statistically, it gives you a better percentage of uptime than having a 1+1, a main and a backup transmitter. And again, the transmitter, the business in Europe for transmitters is all based on service level agreements. The transmitter companies, all they do is run transmitters. They lease time on the transmitters to the program providers, the program creators. And so it's all service level agreements as far as, are the stations able to stay, on power and on the air, what percentage of the time. So they're all about the resiliency and the redundancy over there. So the full redundant 5 kilowatt list for $48,200. That's the current price list here as of the beginning of 2023. So obviously your favorite broadcast equipment dealers are going to be able to, and we work with all of them. They'll be able to give you a discounted price on that.
Can these be retrofitted to existing transmitters in the field,
Yeah,
or
anything that was built after 2010? So anything that has the silver Acrezo faceplate or the Crown E series, those are Acrezo hardware as well. So anything since about 2010, we can do a software upgrade and pop the Smart FM in the license.
and for any other manufacturer, that's strictly a licensing deal. if they make a deal with you guys,
Right. Yeah.
they can do what they can do.
We'd have to look at the architecture of their designs and see if what we're doing it can be implemented the way they've built their transmitters. And then if they see value in that, then we'll talk financial terms and maybe give them the option of offering the technology in their own wares.
You mentioned that you offer it as a annual license or a perpetual license.
Correct.
Talk about that a bit.
Yeah, the annual license, again, the electricity costs around the world vary to such an incredible degree. Originally, when we were dealing with Smart FM, we wanted to do it as a kind of a revenue sharing. The software on the transmitter would track how much power was saved, and based on the cost per kilowatt hour, the broadcaster would split that savings, share those savings with us. But that just got too insanely complicated because, again, the power prices are all over the place. And a lot of times the broadcasters aren't really sure what their cost per kilowatt hour is. Some of the utilities vary the cost per kilowatt hour based on the time of the day or the day of the week. So it just got really, it was just an unwieldy way to do it. So we just went to a flat license fee, and we figured with the cost per kilowatt hour, we used a 16 cents per kilowatt hour as a benchmark. And with that, you would be expected to recoup the cost of an annual license in 6 months. So the license would cost you about half of what you're going to save with your electricity. And with the perpetual license, I think we based that on 2 years or 3 years to recoup the cost for the tech. I think we mentioned that in the PowerPoint, if I'm not mistaken.
Yes, it did say. 3
Yeah.
years.
So yeah, that was the plan anyway, so that you would get a return on investment after a certain amount of time. You'd be expected to see a return on investment.
So the pricing, though, just to be clear, it's no longer based on an individual power cost in a different country or whatever, but you have a
Nope.
set price.
Set price, correct.
Is it set for the US or for Germany?
Yeah, it's actually a different price for US broadcasters because like I said, the power over here just tends to be insanely inexpensive by comparison.
By comparison, yes, I would agree with that. Any more questions from the field about this software process?
What is the lowest in terms of percentage of typical carrier level would it drop to? I remember us hearing 40%.
No, your total savings can be up to 40%. The
Okay.
carrier level will drop down to about 50%. If the algorithm is given free rein and the program material is suitable for that kind of treatment.
And you said, so the time constant that it's evaluating is somewhere in the order of hundreds of milliseconds?
Yeah, again, I'm not familiar with I know that the adjustments happen several times per second.
Okay.
So it's got to be thinking pretty quickly.
Does it drop a pilot?
No, I mean the all aspects of the signal are still there in relative proportion to one another. It's just the overall RF level comes down. So the modulation, pilot, the RDS, everything that makes the FM is still going to be intact. It's just going to be a little bit weaker in the field.
I had two thoughts. One is it might be interesting to put an AM radio on one of these signals to see what it sounds like. I don't know if you've done that or not. My other thought is this system seems like something that would work really, really well in a situation where you don't have heavy co-channel interference. But it probably would suffer a lot with we have one station that's got a very bad co-channel interference situation from a station far away on top of a mountain. And as it sits right now, we have to use HD in order for people to be able to listen in the town.
Right.
Obviously, this would not be a candidate for that. But have you done any testing in terms of, like almost anomalous co-channel situations where the interference is more than you would expect? Does this hurt significantly?
We did some the testing that Jerry and I did in Illinois. We had some adjacent channel interference up in the northwest towards Chicago, or northeast part of the coverage area towards Chicago, and we did notice that the encroachment was a little bit more if the Smart FM was enabled. But again, it was at a point where you really couldn't have been listening to the primary signal anyway, at least not comfortably. And it's not mandatory. We're asking all of our testers to be assured that if there's something that is not working about the technology, you can turn it off, you can change the settings, you can make it less aggressive. And like you say, maybe there are some situations where it's just not going to be an option because you're fighting for every last milliwatt per meter out there in the field to try and beat back an opposing signal. And in those cases, maybe Smart FM is not the best option. But in your 6 other transmitter sites, maybe it is. And that was the thing about the Germany and France adopting this technology. Almost all of the transmitters in France are 1 kilowatt or below. There are only a few 10 kilowatts transmitters in the whole country, and last I knew they were all at the Eiffel Tower site. And so the savings per transmitter are pretty minuscule, even at their increased power costs. But like TDF is running 400 different transmitters across France. So, little by little, it all adds up.
Hey, question. I missed part of the presentation. Is there an example online where there's a nice pristine recording where we can hear examples for ourselves?
Yeah, not really. I mean, most of the testing that we've done has been mobile. We do have software that can do that.
Got it. And
I will see if we can endeavor to get out to one of our testing sites and do some evaluation. So we can, and that is the best way to evaluate it, because you don't want to look just at the RF level from a signal strength meter, because that is going to change. It's the laws of physics. But what's important is the perceptual, is what the listeners hear. Yeah. And that would be, I think, a very interesting, if we drove a particular route, listening to a station without Smart FM enabled, and then drive the same route, listen to it with it enabled, it would be challenging to be able to compare, because you want to be able to compare the same spot, right? The same physical location with the Smart FM on and off. And that's kind of hard to do with an audio recording.
So it wouldn't be scientific, but it would be a good reference for us.
Sure. Yeah, absolutely. Maybe just a short clip, 30 seconds or a minute or something like that, just to say, here's this stretch of highway that we drove with the Smart FM on. But in general, if you're inside the 60 millivolt contour, the differences are not going to be audible.
Yeah, and so it'd be nice to show a programmer or a manager the results. Hey, you could do it on a 2 for Tuesday. Play the same song twice and go back and forth.
I think that's not how 2 for Tuesdays work.
I know, but I've got my own variation.
Okay.
And do it on April Fool's Day.
Okay. Perfect. Then nobody will believe us.
Yep.
Mike's idea is a good one if you can find a particular spot where it's right on the edge, and you could show this site is where you can actually hear the difference, or a site where you are at a 62 dB and you won't hear it.
Yep, that's generally the experience that we've had. If you're in the primary coverage area of the station, what it's licensed to cover, you're not going to hear a difference.
Well, again, as Mike said, it'd be nice to hear it.
Yeah, it's a good suggestion.
Did you say you had some additional slides showing some aspect here?
Let me see. I've got to pull up another PowerPoint real quick. So this is from our tester in Kansas, Colby, Kansas. So you can see basically it keeps a chart graph of how much savings have been generated from week to week, and you can see the potential benefits over the course of the year. This is at 9 cents a kilowatt hour. So his estimated annual savings are only going to be about $382, 4,200 kilowatt hours, and that ends up being about 2,500 kilograms of CO2. So there's that.
You can make it
and-
full screen if you want.
Yeah, let's when I do that, it always goes back to the beginning,
Oh,
which is irritating. So there's that one, and we look at this one also from KTCC. This one, he was a little more aggressive with the processing on this one and the SmartFM algorithm. So the savings were up, and his predicted annual savings were a little over $450 a year. So yeah, 9 cents a kilowatt hour. It's you're not going to see that's from WVLI in Kankakee there. They were also saving about $520 a year. So yeah, at these power costs, the monetary savings are never going to be all that impressive, but hey, $500 a year is $500 a year. 10-year life of the transmitter, that could pay for 1 kilowatt.
and if you're running 5 or 10 kilowatts, you're probably looking at.
Yep, even more. Or if you have 5 or 10 1-kilowatt transmitters, it's all gonna. The only reason WBLI they have a 3 kilowatt there. The only reason they didn't keep using SmartFM after their STA expired is that they don't pay for the power at their site. It's included in the tower release.
Well, that's a good idea for folks that are negotiating
Yeah,
a new tower site.
yeah, give us free electricity. It's always good. I worked for a station in Honolulu one time that when I got there, they had just a year or so moved into a new space in a new office building, and beautiful office building, really modern. That was all terrific, but they had neglected to negotiate 24/7 air conditioning into their lease terms. And so they had to go back and pay an enormous extra fee to get to keep the studios and offices cool for people that were working nights and weekends. Oops.
Yeah, I would say. Any other questions, folks? Anybody want to consider next time you buy a new transmitter, you might want to look at the Acreso?
Yeah, it's kind of a little bit of future proofing, because the power is not going to get any cheaper. It'd be nice to have a transmitter that had this capability in your hip pocket if it comes to it.
Mhm. Well, Tony, I sure appreciate your taking the time to share this information with us and help us to appreciate what you're doing. And I think I speak for everybody. We all look forward to hearing some of this audio that you might come up with as a
Sure.
And you will be at NAB as well.
Of course. West Hall, booth 2123 or 2321, something like that. We're near Orban. You won't have trouble finding us.
Put that in the newsletter as well. So anyone that's got the newsletter, or go up here to news on the website and take a look at this week, and you'll see it.
It's great. Well, thanks everybody for spending some time with us. Thanks, Barry, for the opportunity. As always, good to talk with everyone, and we'll hope to see folks out at NAB.
Look forward to seeing you. And I won't make it this year, unfortunately, but a number of will, and we hope that they will come get a free floor pass and come see you.
Sounds good. We're there.
Thanks, Tony.